Welcome back to Massetti's Math Movies, where it's cute to be a square. Today's lesson is 10.5 sine and cosine ratios. By the end of the lesson, you'll be able to use the sine and cosine ratio to solve sides in a right triangle. Previously, we learned the tangent ratio to find sides in a right triangle because we don't always have the angles that we need to use our special triangles. We don't always have 45, 45, 90. We don't always have 30, 60, 90. So that's when we use tangent and sine and cosine. Now you may have remembered in tangent was opposite over adjacent. So we never got to use the hypotenuse. We get to use the hypotenuse for these. So this is a trig ratio that equals the opposite leg over the hypotenuse. So this is how we're going to get to solve for the hypotenuse. Cosine is also a trig ratio, but it's equal to the adjacent leg over the hypotenuse. The abbreviations, this abbreviates to sine, like this. It looks like sin, but we always say sine. We never say sin. And this abbreviates to cosine like this. We don't ever say cos, we always say cosine. And those are on your calculator right next to tangent. So now you can pick any ratio you might need. So here's sine, cosine, and tangent. So let's practice here. I'm going to give you a way to remember this. So a device, or a memory device that I like to use is called SOHCAHTOA. SOHCAHTOA. And if you can remember SOHCAHTOA, you can remember what goes with what. So is for sine, because sine is opposite over hypotenuse. See the so. Cosine is adjacent over hypotenuse. So and we learned tangent is opposite over adjacent. TOA. So if you can remember SOHCAHTOA, you can remember which is which. So down here we have sine. Sine is opposite over hypotenuse. So this is where we're standing. We're standing at A. That's how we know what the opposite is. So opposite of where we're standing is little a. The hypotenuse is always across from the right angle. That is C. And we can never stand in the 90-degree angle. Remember, you never use 90 because then the opposite and the hypotenuse become the same thing. That doesn't work. That's why we never stand in 90. Cosine of A, so we're standing in A with a cosine. Cosine is adjacent over hypotenuse. Well, what's next to us? Little b is the side that's next to us over the hypotenuse, which is little c. So now we're going to practice cosine of A and sine of A. So this is where we're standing. We're standing at A. So draw yourself standing at A. So sine is opposite over hypotenuse. So opposite of where we're standing, what side is opposite? The opposite side is 3. And the hypotenuse is always across from the right angle is 5. Cosine is adjacent over hypotenuse. So what's next to us? What side is next to us? 4, or which leg is next to us, and the hypotenuse is 5. So the cosine is 4 over 5. All right, now it's your turn. Find the sine of A and the cosine of A. Sine of A, cosine of A. Leave your answers as fractions. So I want you to do this now. I want you to simplify your fractions. Sine of A, cosine of A. Sine of A and cosine of A. This is just like example 1. All right, now we're going to do the same thing, but they want us to also write our answers as decimals. So we know sine is opposite over hypotenuse, and we're standing at A, again. Opposite of us is 5, and the hypotenuse is 13. We should probably always, right? Hypotenuse is always across from the right angle. So here's opposite, here's adjacent. So cosine is adjacent over hypotenuse. So adjacent to us is 12, hypotenuse is 13. Now we can put this in our calculator and give the decimal approximation. So all we're going to do is just 5 over 13. 5 divided by 13, 0.3846. 12 divided by 13 is 0.9231. Notice that 7 rounds the 0 to a 1. Find sine of A and cosine of A. All right, this is just like example 2. I want you to do it now. So you're going to find sine of A, write it as a fraction, then write it as a decimal. Same thing with cosine of A. Right? Identify your hypotenuse. That should always be your first step. Go find your hypotenuse. Circle your hypotenuse so you know what you're looking for. Use a calculator to approximate sine 74 and cosine 74. Round your answer to 4 decimal places. So they're just asking us to put this straight into our calculator. So we press sine 74, enter. All right, that's quite long. It's quite a ratio, 0.96126165959. Into 4 decimal places, 9613. Notice that 6 is going to round that 2 to a 3. Cosine of 74. You press cosine 74, enter. Also quite a decimal. And that stays. That 3 is going to keep that 6 the same. So you're going to do this now. All you have to do is use your calculator. This is like example 3. Do now, and we want 4 decimal places. All right, now here's where we get to put it all together. Put the ratio and the calculator part together we want to solve. I don't have a triangle that has 32 degrees in it. This triangle is close, but it's not 32, so I can't write a proportion here. So that's why I have to use my calculator, because my calculator has all the ratios in it already. So let's say I want to find A first, little a. Well, if I'm standing here, like this is the hypotenuse, let's stand here, so that's the angle they gave me. See, this is the opposite, this is the adjacent. So they gave me the hypotenuse, and I'm looking for the opposite. So opposite and hypotenuse is sine. So I'm going to write my first equation. Sine, and then where I'm standing at 32 degrees, equals opposite, which is little a, over hypotenuse, which is 10. Here's my proportion. I'm going to cross multiply. So I don't need to divide by 1, that doesn't matter. A is approximately. So I do 10 times the sine of 32, 5.3. So there's A. Now to find B, notice B is the adjacent. So I need the adjacent, and they gave me the hypotenuse. So adjacent and hypotenuse is cosine. So I write cosine of 32. Cosine is adjacent over hypotenuse. Adjacent is little b, hypotenuse is 10. Once again, I'm going to multiply 10 times cosine 32, 8.5. B is approximately 8.5. Find the lengths of the legs of the triangle. Round your answer to the nearest tenth. All right, I want you to do this now. This is like example 4. You're going to have to write 2 equations for each one. I want to see your equations. Down here is just a little review. So the tangent, remember tangent, that's TOA, because we've got TOA. So tangent is opposite leg over adjacent leg. No hypotenuse involved. So if we're standing here at A, this is the hypotenuse, opposite of us and adjacent to us. So opposite over adjacent is going to be little a over little b. Sine is opposite leg over hypotenuse. So if we're standing here at A, here's the hypotenuse, opposite, adjacent, opposite over hypotenuse, A over C. And cosine is adjacent leg over hypotenuse. So we're standing here at A, once again, hypotenuse, opposite, adjacent, adjacent over hypotenuse. Those are your 3 trig ratios. This is M cubed, signing out.